Welcome to TSAT. I'm going to introduce geography today, and I'm going to discuss about the interior structure of the Earth. So, to introduce about geography mainly has got two branches. The two main branches of geography are physical geography and human geography. So, physical geography is science, whereas human geography is social studies. So, geography has got mainly two branches. One is science, that is physical geography. The second is social studies, that is human geography. So, let us discuss what are the different areas or chapters where the geography deals with. So, for example, in the case of physical geography deals with the different areas like geomorphology, climatology, oceanography, and biogeography areas. So, here in this case of geomorphology, geography deals with this geomorphology means that geo means earth, morphology means the external features. So, the external features of the earth are the mountains, plateaus, plains, etc., how they are being formed, what are the different kinds of dynamic forces responsible for the formation of the different topographical features will be the part of this chapter. Whereas climatology deals with the phenomena of weather and climate in the atmosphere. That is what climatology deals with, how these weather pattern changes, how cyclones are being formed, how El Nino, La Nina impacts the climatic conditions, etc., are being dealt by climatology. The composition of air, etc., are being dealt with climatology. And next, oceanography deals with the oceans, the ocean water circulation, composition, etc. And biogeography studies about life on the earth. So it studies about flora and fauna existing across different latitudes. Because of the variation of climatic conditions, there is a diversity existing geographically. So how this flora and fauna variation happens across the globe is the subject matter of biogeography. In the same way, in the case of human geography, it deals with human aspects, where the main concentration of human geography is on area where, in the process of interaction with the environment, human being, for the purpose of development, he exploits the resources from the environment. So in this process of exploitation for the purpose of development, how human being is interacting with the environment is the main subject content of human geography. So in this process, one of the main branches of human geography is economic geography. So in economic geography, it deals with areas like agricultural geography, industrial geography, transport geography, etc. So in the case of agricultural geography, the way it deals with is what are the different kinds of crops being cultivated across different latitudinal regions, what are the different geographical factors which influence the cultivation, according to the environmental conditions, according to the different variant types of soils and topographical features, different crops are being cultivated. So the agriculture is being impacted by geographical factors. That will be the main content of agricultural geography and economic geography. Industrial geography, for example, it studies about the establishment of industries at different regions, because it is the raw material derived from the geographical factors like the topographical factors, which determines the establishment of an industry in a region. So how geographical factors are impacting the locational factors of industries, etc., will be part of industrial geography. Next, transportation geography, which is one of the basic infrastructure, transportation, essential for the development of an economy. A country or an economy develops only when there is a better transportation. So how these geographical factors are responsible for establishing better transportation network, whether it is roadways, railways, or waterways, how these geographical factors are influencing for an efficient trade, etc., will be the part of transport geography. So this agricultural geography, industrial geography, and transport geography together are the branches of economic geography. Next is population geography. It deals with the population, the way the population is being distributed at different parts of the regions, in different regions. For example, there are certain geographical factors which impact the density of a population. Compare the density of population in Bihar, compare the density of population in Bihar with Rajasthan. So definitely the variation in the density of population is because of the geographical factors in terms of the irrigation potential of a region, climatic factors, etc., availability of raw material, etc., determines the population of a region. So in the same way, the regional geography studies about different regions where there is variation in terms of different regions, in terms of population, their culture, agriculture, industry, etc., is being influenced by geographical factors. The human habitations, etc., are being constructed on the basis of the availability of the natural setup over a region. That will be the part of regional geography. Next, the cultural geography studies about different regions of the world and the nation, and it studies the cultural aspects of different regions and how geographical factors are responsible for the variation of cultures of different people. So this is how the scope of geography is, and today I am going to deal about the topic the interior structure of the earth as part of physical geography. So in this context, to know the interior structure of the earth, there are certain methods which are being used to know the interior structure of the earth. So what are the different evidences for us to determine the nature of the earth's interior? Because we have never been too deep into the core of the earth. So at the most we have been to 15 or 20 kilometers or so, but we are able to establish the nature of different layers of the earth interior on certain basis. So what are the evidences available for us? What is the basis on which we establish the nature of the earth's interior? So this is the basis on which we establish the nature of the earth's interior. So here, in terms of the variation of temperature, variation of pressure, variation of density, behavior of the earthquake waves, these are the different factors which helps in estimating the nature of the earth's interior. The reason behind it is with the increase in the depth, when we are going to the earth's interior, the temperature gradually increases with the depth. So the other factor is pressure. So with the increasing in the depth, the overlying mass of the earth layer increases because of the weight being increased. What happens is the pressure with the depth gradually increases with the increasing in the depth. That is how the depth varies with the increase. That is how the pressure varies with the increase in the depth of the layers of the earth. Next, the density. The density also increases with the increasing in the depth. So gradually, the earth is majorly or broadly being divided into three major layers. Apart from these factors with the variation of temperature, pressure and density, the other factors which help us to study the earth's interior is the way the waves behave, the earthquake waves behave when they are passing through different layers of the earth's interior. The reason behind it is when the waves are being passed through the different layers of the earth's interior, when the density of the earth's layer varies, the velocity of the waves varies. When the state of the layer varies, if it is a semi-solid layer or if it is a liquid layer, certain waves pass through liquids, but certain waves doesn't pass through liquid. So based upon the velocity of the wave passing through different layers of the earth's interior, depending upon the way the waves pass, whether passing to certain layers or not passing through certain layers, determine the nature of the earth's interior. So let us go by point to explain you, to make you aware how the layers of the earth interior exists. So basically, to understand the earth's interior broadly, the earth has got three major layers. The outermost layer is the crust, the blue layer. The outermost layer is the crust, which is the thinnest layer. The thickness of the layer of the crust varies from 4-5 kilometers to at the max around 70 kilometers beneath the highest mountain ranges, and it is thin at the oceanic crust regions. So the next layer is the mantle. The crust, the second layer is the mantle, and the inner layer is the core. The inner core is being divided into outer core and the inner core. So These are the main three major layers of the Earth's interior. After knowing the major broad divisions of the Earth's interior, layer by layer, we shall analyze and discuss how the density varies, the nature varies, the thickness varies, and the composition of the layer with different kinds of minerals with which the layers are made up of. Let us discuss by layer. So here, when we consider the structure of the Earth's interior, we have got different layers. As I have mentioned, the reason for the division of the Earth's layer into different layers, because there is a change in the nature of the layer in terms of density, in terms of thickness, depth, behavior, etc. So because of these reasons, the layers of the Earth interior is being divided into different layers. So in this context, the first layer is the crust. So the crust of the Earth is being divided into two parts of the crust. Especially, it is being divided into oceanic crust and the continental crust. So the crust beneath the ocean is being described as the oceanic crust. The crust beneath the continent is being described as the continental crust. So in this context, when you relatively compare with the thickness of the crust, the thickness of the continental crust is more than the thickness of the oceanic crust. But when you relatively compare with the density of the crust is considered, the density of the oceanic crust is more than the density of the continental crust. So in this context, composition of the Earth's crust. So oxygen is the predominant element present in the Earth's crust. 50% of the weight of the almost all 46 50% of the weight of the Earth's crust is because of the oxygen combined with silicon forming minerals. Next to oxygen, it is silicon. It is 27.7%. Aluminum is 8.1%, and calcium is 3.6%. Iron is 5%. Sodium is 2.8%, and potassium is 2.8%, and magnesium is 2.1%. So here, these are the different materials with which the Earth's crust is made up of. So in this context, to understand the interior of the crust is being divided into majorly the continental crust and the oceanic crust. So the continental crust is being described as 𝗂𝗧. 𝗂𝗧 here implies silica, and it is made up of silica and magnesium, and whereas the continental crust is made up of Cl, silicon and aluminum. So this is how the materials which are dominating when you relatively compare with the continental crust and the oceanic crust. So the thickness of the crust varies. The continental crust is much more thicker, whereas oceanic crust is much more thinner. The average thickness of the crust is 40 kilometers, where it may vary to 70 kilometers beneath the mountain ranges, or it may be very minimum at the trenches deep in the ocean. So that is how the thickness of the crust varies. So the next layer is the mantle. So the mantle is being divided into the upper mantle and the lower mantle. So in the upper mantle, when we consider the upper mantle, the uppermost part of the upper mantle is considered as an asthenosphere, means which is in a state of plastic. A plastic is a material. A plastic state of condition of a state is one which can be deformed with pressure. For example, to make you understand the condition of the upper part of the mantle, for example, rocks in the atmosphere, in the air, when we try to bend the rock, we cannot bend the rock. Rock either cracks or you cannot break the rock. You experience only these two conditions. But at a certain conditions, at the asthenosphere, because of the temperature and pressure conditions, rocks bend. So here, this is a kind of condition where the uppermost part of the mantle is considered as the asthenosphere because of temperature and pressure. The layer is described as a plastic one which bends to or deforms to pressure conditions. So the upper part of the mantle and a layer known as mohawiric discontinuity, and a crust together known as lithospheric plate. This is known as a lithospheric plate because this layer together known as the crust, the mohawiric discontinuity, and the upper part of the mantle, a part of asthenosphere, which is in a plastic state, is a dynamic one, means which move from place to place because of the endogenetic forces. Endogenetic forces means the forces which are being developed within the Earth's interior because of the magmatic activity, which is responsible for the sliding of the lithospheric plates from region to region. Because of these sliding of the lithospheric plates throughout the Earth, which consists of both the oceanic lithosphere and even the continental lithosphere. Because of this movement of the plates, there are many fracture zones of the lithospheric plates. These fracture zones are being described as plate boundaries. The fracture zones are being described as plate boundaries. Because of these kind of fracture zones and because of the sliding of the lithospheric plates on a semi-solid layer leads to formation of different kinds of plate boundaries. So, because of the movement of these plates, this lithospheric plate, which consists of the upper part of the mantle, mohawiric discontinuity, and the crust. A discontinuous layer in the Earth's interior implies that it is a semi-solid layer. So, here the lithospheric layer with these different layers will be sliding over a semi-solid layer, leading to the formation of different plate boundaries. This is a kind of plate boundary known as a divergent plate boundary. Means because of the fracture zones of the lithospheric plates, because they are sliding because of the semi-solid layer available above the upper part of the mantle known as the asthenosphere, plates diverge in a plate boundary. In this divergent plate boundary, because of the molten magma available and the semi-solid layer available beneath the plate. So, the movement of the plate is because of semi-solid layer available beneath the lithospheric plate and the magma, molten magma pressure being available from the mantle is responsible for the movement of the plates. So, in these plates, when the plates are moving in an opposite direction, look at the arrow mark direction, leads to the divergence of plates. The gap being formed is being filled with the magma, and this magma solidifies, leading to the formation of a new lithosphere. So, here the lithospheric plates are being constructed. That is the reason why this boundary is also considered as a constructive plate boundary. So, apart from this, a different kind of plate boundary known as a destructive plate boundary or a convergent plate boundary, where the plates or the plate boundary on the other side, it converges. Here, apart from the construction of the lithospheric plate, the plates are being destructed here. So, because the rate of construction and destruction are balanced, the surface of the Earth is remained constant. So, this is the second variant of plate boundary because of the lithospheric plates moving over a semi-solid layer. So, the next type of plate boundary is known as this transform plate boundary. It is neither constructing the lithosphere nor destructing the lithosphere. It just slides. And when you relatively compare with the different intensities of earthquakes being occurring, the intensity of earthquakes relatively compared in these different kinds of plate boundaries, the intensity of earthquakes in these plate boundaries is relatively less when compared to the destructive plate boundary or the constructive plate boundary. So, that is the reason why the lithospheric plates are considered to be dynamic, which are not static, which are constantly moving from region to region. So, after knowing this, we shall get into the different layers of the Earth's interior. So, this is what a lithosphere is. The lithosphere is a solid rock that covers the planet. This includes the crust as well as the very uppermost part of the mantle, which is solid rock. All of the rocks on Earth, from the mountains to the seafloor, is included in the lithosphere. So there is a layer known as Mohawiric discontinuity within the lithospheric plate. So as I have already mentioned that Mohawiric discontinuity or discontinuity in the earth layer implies that there is a change in the state of the layer, there is discontinuity in the state. The discontinuity is discontinuity from a solid to a semi-solid state. So one such discontinuity is existing here beneath the Earth's crust in the lithospheric plate. So this is considered to be megacontinent, which is known as Pangaea. Because of this movement of the plates, the Pangaea, the larger continent, is being divided into Laurasia and Gondwana. So this Gondwana is further divided into these South Asia, Australia and Antarctica. Laurasia is being divided into North America, Greenland, Europe, and northern part of Himalayas, the China and the Russia constitutes Laurasia, and Laurasia is otherwise also known as Angara land. It has got a secondary name. So with this kind of drift of the continents, because of these semi-solid layer beneath the lithospheric plate, has led to the existing configuration of the continent. So gradually, when you relatively compare with the millions of years, so this is the configuration of the continents around 225 million years ago. Gradually, because of this drift happened, gradually the continents have drifted across different latitudes gradually, and this is the existing present day configuration of the continents because of the dynamic nature of the Earth's interior. So because of this reason, you have got different plate boundaries. When you relatively imagine the crust or the lithospheric plate completely above the Earth, consisting of convergent, divergent and transverse plate boundaries. When the surface of the Earth is considered, the crust is considered, there are certain elements which are existing with which the crust is made up of. Predominantly, as I have already mentioned, oxygen is a predominant element. You may get a doubt that oxygen is a gas. How can it exist? Oxygen is in the form of a mineral, in the form of a molecule reacted with some other element. That is the reason why it can exist in a solid state. So this is the same thing is been represented in a pie diagram for the purpose of your understanding, which is being discussed with you. Next comes the mantle. As I have divided the mantle into the upper mantle and the lower mantle, basically the mantle is made up of silicates and iron and magnesium. So this is the composition of mantle. So the mantle is the second layer, which is being divided into upper mantle and the lower mantle. The upper mantle's upper part consists of the asthenosphere, which is at a plastic state. It means that which can be deformed because of the pressure and temperature conditions. The upper part of the mantle has been described as an asthenosphere. So how it is being described? Beneath the lithosphere lies a soft, comparatively weak layer known as the asthenosphere. Within the asthenosphere, the rocks are close enough to their melting point that they are easily deformed. Because of the pressure conditions, they can be deformed, they can be folded, etc. The asthenosphere is weaker because the rock is near the melting point, just like hot wax is weaker than the cold wax. The lower lithosphere and asthenosphere are both part of the upper mantle. So the boundary between the crust and the mantle is known as the Mohawiric discontinuity. Mantle, the upper mantle and the lower mantle together consists of 2,895 kilometers, which is made up of magnesium ion silicates, as I have mentioned already. Boundary between the mantle and the core is known as Weizsäcker-Gutenberg discontinuity. So already I have mentioned discontinuity is a change in the state which is considered in the earth layers as a semi-solid state. So the next layer is the core. Core is up to 5,156, the outer core, and the inner core is 6,371 kilometers. To the core of the center of the earth, the distance is, and the composition of the core consists of a knife. Ni stands for nickel, Fe stands for ferrous. This is the composition of the core of the earth. So, as far as the state of the core is considered, the outer core is considered as a liquid and the inner core is considered as solid. But to the known human knowledge, no material can withstand in a solid state to the existing temperature and pressure conditions. So, but it is behaving as a solid. So, what is the basis on which we are able to establish the nature of the state of the layers of the earth interior is on this basis of the way the waves behave. So, while the different waves are being passed through the earth's interior, we are able to estimate the time being taken to travel and the way the behavior of the nature of the waves. We are able to estimate the layers of the earth's interior. So, when these different waves like P waves, which are described as the longitudinal waves, S waves, which are considered as the transverse waves, L waves are discussed as surface waves. The waves, the way they behave in these different layers which I have discussed are different, based on which we have established the nature of the earth's interior. So, when we have passed these different waves through the layers of the interior of the earth, so there are certain waves known as P waves are able to pass through all the layers, whereas in the case of S waves are considered, S waves are not able to pass through the core. So, it implies that we know the nature of these waves, whereas S waves cannot pass through the liquid. So, that we have established that the outer core is liquid. So, because it is a liquid, because the S waves cannot pass through, they are being deflected from the core to different directions. Whereas P waves nature, where they can penetrate into the earth's interior and into the outer core and the inner core. But because of the change in the density of the layers of the earth's interior, these waves are being refracted, because of which you are able to observe certain bendings of the waves when they have changed the discontinuous layer. Here the changing layer is the Mohoviric discontinuity, or in the case of the core it is a Gutenberg discontinuity, the Gutenberg discontinuity between the mantle and the core. So, because the change in the density, the waves are being refracted. So, with this we are able to conclude that the crust is solid, the mantle is solid, the outer core is liquid, the inner core is a solid. So, here in this context, we are able to determine the shadow regions of these waves. So, here in this case, we have got a shadow region. So, for example, the P wave shadow region angular range, or a S wave shadow region angular range may be asked. So, in this context, as per the diagram being shown to you, as you are able to observe the way the waves are behaving, where the S waves are being diverted away from the outer core, where they are not able to penetrate because the outer core is liquid, because the S waves cannot pass through the liquids. So, that we have determined that the outer core is liquid and the mantle is solid and the crust is solid. Whereas in the case of P waves, where they have got the capability to penetrate into the liquids also, we are able to estimate that the outer core is a liquid. So, with the time duration of the travel of the waves, we are able to estimate the distance traveled by the velocity of the wave, and we are able to establish the thickness of the different layers of the Earth's interior. So, with this we are able to establish that the angle of shadow region being formed by these waves. So, when you relatively compare here, because the S waves cannot travel through the outer core, the shadow range varies from it has got a very large shadow region from these 103, 104 degrees from either side, from one side of the earth to the other side of the earth. But it is not the case with the P wave shadow region, which is just extending from 103 degrees to 105 degrees on either side of the earth, whereas it is not having a shadow region in between. So, On this basis, we are able to establish the interior of the earth. Okay friends, next time we shall meet with in a next topic with you.